are going to go around campus and learn a little bit about all the projects that we conduct on campus in different buildings. So let's get started.
So when we looked into the control system, we couldn't quite figure out why the fan wasn't responding to its commands. So we wrote a work order for the building maintenance teams, and they went and investigated the unit, and they found there was a wiring issue. So once that was corrected, the unit finally responded to its off command, and we were able to make it follow its schedule. So that was a big energy saving project. Last year, all these things that we do across campus to catch those little issues added up to something really big. We saved $250,000 just from all these deficiencies that we fixed and that were brought to our attention. So this is a really big project from an energy perspective, and we're having a big impact by fixing all these cross-campus issues that don't get noticed.
If you haven't heard about Trim the Waste, it's another interactive website that we have, and to go on there, it takes 15 minutes. You learn about how energy gets onto campus and how you can help us save energy or pinpoint buildings that are wasting energy.
Hi, I'm Hiroko Masuda. I'm an energy engineer at the Energy Conservation Office. At Shields Library, we are trying to optimize HVAC systems operation for energy efficiency. For example, at one of the air handlers, we could change the programs so the fan uses less energy while it maintains the same amount of airflow to the space. This is outside air intake section. So this is the damper to be replaced with the new damper.
Intern at the Energy Conservation Office. This week we're talking about PES and what makes it a green building. PES was actually the first in-use academic building in the United States to receive a Green Excellent rating.
Now let's go behind the scenes into the basement of PES. In the basement is the mechanical room, and we often take new student interns down into the basement to learn about the heating hot water and chilled water systems that heat and cool the Plant and Environmental Sciences building. John Kuhn is a part of the facilities staff with over 15 years of experience with campus buildings. John shows our students the mechanical equipment that makes heating and cooling possible in buildings. This includes how steam comes from the central heating and cooling plant into campus buildings through underground pipes. The steam enters the mechanical room and through the mechanical equipment is used to heat the building, and then returns to the central heating and cooling plant as condensate. This is the Sciences Laboratory building. Buildings with lab spaces are often the most energy-intense type of building on campus because of their required ventilation. The air coming into the lab must be 100% outside air, and then it must completely leave the building. Moving this quantity of air with fans along with heating and cooling the air is an energy-intensive process.
Giedt has occupancy sensors for its lighting that make the building more energy efficient. The building also uses shade, reflectance, and open grid paving in order to reduce heat impacts. These features and others make Giedt another LEED Gold certified building on campus. One of ECO's main objectives is to use feedback from students and staff to improve comfort on campus. In 2017, we implemented the Giedt Hall fan project.
With the Giedt Hall fan project, students and faculty can go to thermostat at thermostat.ucdavis.edu. If they enter Giedt Hall and room 1001, their votes will control the speed of 2 high-volume, low-speed ceiling fans. Warm and hot votes will speed up the fans, while chilly and cold votes will slow down the speed of the fans. These fans were installed to better circulate the air in the classroom without creating a draft.
A little fun fact, if Giedt was powered by students or biking students, it would take 396 biking students in each lecture hall to run the entire building, which creates 38,996 watts per hour.
So another project that we have going on in ECO is SWARM, which stands for Small Workplace Automation and Remote Monitoring.
So we are standing here inside the barn. This is one of our SWARM buildings, and we chose this building because it's one of the larger small buildings on campus that isn't connected to any central control, and it had a lot of different systems working in it that conflict sometimes with one another, and the thermostats weren't programmed optimally. So we came in here and installed new thermostats, and were able to detect when thermostats were making units run when people might not be in the spaces, or also diagnose problems if a heater's broken or something like that.
Hi, my name is Sam Cole. I'm an engineer with ECO. So we're at Ghausi Hall today. We're here to tell you about a project we did here, completed a few years back. And it was one of the first large whole building projects that we did as a team. It was very complicated. We learned a lot from it and saved a lot of energy. So one of the coolest things we did in this building for this project is we used occupancy sensors that you usually see for a light, and we tied them into the heating and cooling system. And so in the labs and in the offices, when nobody's in there, we let the airflow reduce a whole lot, and that makes the fans really happy, and they don't have to work as hard to move air. We also have the temperature strip a little bit more to let the heating and cooling system relax a little bit. It's really neat because it saves energy on weekends or working in the labs at night. But then the second they come in, it comes back to keeping it nice and comfortable and ventilates. So it's almost as if you couldn't even tell the difference in the building. But the utility meters are also pretty happy.
Now we're at the Mathematical Sciences building. This building has an energy-efficient HVAC system, which is monitored and remotely controlled by our office. It uses 33% less energy than similar office buildings and 18% less water than comparable buildings due to low-flow restroom fixtures. The surrounding surfaces qualify as high reflective materials that reduce heat absorption, and the area around the building has a lower reflective index or is shaded by vegetation, and this minimizes the impact on human and wildlife habitats. All of these features contribute to the Math Sciences LEED Gold certification.
Thank you for joining us.